small, we need to see them under the microscope, but they do not have any color. So seeing a colorless thing like a glass thing under the microscope, difficult. So we give color to the bacteria or we stain the bacteria. Okay, this is what we are going to learn today. There are some techniques. We will leave out the wet mouth. We will do gram staining techniques for you. Okay, so we will see different methods of staining. How we give color to the bacteria. Okay, there can be two types. Okay, one is general staining or simple stain, and the other is the differential stain. Simple stain means that we give any color to the bacteria, for example red, blue, etc., and it will appear red or blue. Differential stain means that it can differentiate between the types of bacteria, gram positive or gram negative. Okay, acid fast and non-acid fast. Okay, these are the two techniques that are called differential stain. Differential means to separate between two types of bacteria, and you have already had lecture about gram positive, gram negative. So what is gram positive? What is gram positive? Why? Has? Everyone has.
One layer.
One layer.
Live only and the gram negative.
Fat kind of like in thick layer. Okay? When it takes up stain, it does not give out the stain. Simple. And gram negative has thin peptide molecule layer. It takes up stain and gives out the stain. Okay? So we have gram staining. This is very important. Gram stain. Why? It divides the bacteria into two types. Gram positive, gram negative. And then we classify again gram positive, cocci, bacilli, etc., etc. Different types of bacteria. For example, if we know which type of bacteria, we can find different antibiotic which will kill that bacteria. And we can help the clinician. If you are a doctor, which you will be inshallah working in the hospital, one person comes to you, he says, I have infection here and there, or he has problem fever. You will see, oh, if he can have bacterial infection, viral infection, or fungal infection. If he has bacterial infection, which bacteria? Gram positive or gram negative? There are different antibiotics for gram positive, different antibiotics for gram negative. Okay, so this is why it is important to differentiate gram positive and gram negative preparation. Just leave this out. We go to staining techniques. Okay, so there is a process by which you give color to the bacteria or stain the bacteria. The process is called, there are two steps. Okay, to be familiar with the preparing process of smear. What is the smear? Okay, you know smear? Yes, in hematology. No, that is hematology. Okay, it's a similar thing in microbiology to prepare a smear. If you take a slide like this, you put a drop or some amount of bacteria and you spread. Make big like this, like nusreal. Okay, like this. When you spread it, you are spreading bacteria. Okay, if you make thick smear, you have multi-layer of bacteria. If you color the top, bottom will not color. You will have difficulty identifying. So there is a process of making smear. Every type of staining, you first have to make what? Smear. This is very. If you make a good smear, you make good stain. Okay. Most probably, all of you will not find seats to sit. So you can use the bench to sit, or you have to stand. Okay. Just bear with me. It won't take more than 20 minutes, inshallah, and then we will be able to do the practice. Okay. So first thing is the process of preparing smear, and then we do the staining. Okay. So how do we prepare a smear? Okay. All of you have seen this. What is this? This is a wire loop. I'll write, I know, wire loop. W-I-R-E-L-O-O-P. Not loop, not lobe. Okay? Loop. Okay? Wire loop. Why? You see the circle inside here?
Yes.
Okay, this is used for taking bacteria from here and transporting it. So if you see, you know bacteria everywhere. When we need to transport bacteria from here to there or mix bacteria or mix smear, we first need this loop to be sterile. If it has already got some other bacteria on it, it will mix with the bacteria that you are taking and it will cause problem. And this thing here is called what?
Heater.
Not fire, not heater. It's called incinerator. Okay, this is
Incinerator.
incinerator. You know incinerate? Khalas. Okay? Ashes. People incinerate their bodies in America and British because they don't want to bury and remember people. Okay? So how do you do that? Sterilization, you just put the loop inside here. You wait 20-30 seconds. Because it is very hot inside, it's written caution hot. That is not the name. Okay? It just means it's very hot, do not touch. Okay? You just put in there and when you take out, you'll see it's red hot. You see that?
Yes.
So that means it has sterilized all the bacteria and this loop is now sterile. So first thing is what? Flame sterilize the loop or needle. You can sterilize here or you can use Bunsen burner. You can use the burner like this on the burner and you sterilize your flame. The first thing is sterilize your loop. Sterilize your loop. Okay? Once you sterilize your loop, first step, flame sterilize your loop before and after use. Before and after use. You sterilize the loop. This is bacteria, okay? These lines are bacteria. I take bacteria, put on slide and then I put it here. If I put it here, the bacteria from here will go to the bench. Then I stand like this and I take the bacteria on my hand. So before and after using the loop, you sterilize. Before and after. Okay? So what's written? Before and after. The whole wire from here to there, it will be sterilized and you put inside. So first step, sterilize your loop. Second step, this is two types of things, okay? You see this cloudy thing? This is liquid culture. Liquid. You know culture? Not heritage. It's culture, like mazra, growing. Okay? So we grow bacteria here, and we grow bacteria here. We can grow bacteria in liquid, we can grow bacteria on solid. So this is liquid culture, this is solid culture. Both of these have large amount of bacteria inside. So you can have liquid culture and you can have solid culture. So what you do, you sterilize your loop depending on what you have. If you have solid culture, you take one slide and put a drop of distilled water on it. Okay? I'll show you how to do it. You take one slide, put a drop of distilled water, take one colony and mix. When you mix, make it big like this, one part of the smear is done. You got it? You sterilize your loop, you put one drop of distilled water and you mix the colony. Okay? Next you spread. Next thing, you air dry. Once you have got something on the slide, you just leave it for 2 minutes, 3 minutes. So it is dry. Okay? You air dry. Sterilize your loop, take one drop of distilled water, mix, air dry. For solid culture. Okay? For solid culture. So when it is dry, you will next thing, heat fixing. What is heat fixing? You've got a wooden faucet there. Could you pick it up? There in front of you. For example, this is my slide and I write first thing here, this is sample A. Why? Because I want to know where I am putting the bacteria. If I put the bacteria here, and then I forget, I'm talking and my mobile is ringing, and then I do like this, and I put color stain here, no stain. Or I forget, and the next step, that is heat, fix, I do like this, I burn all the bacteria. So I have to remember which side I am putting bacteria. For example, if I do like this, it is very difficult to judge which side it is. So always mark the side, and when you hold the forceps, put the bacteria on the smaller edge. This small side, put the bacteria. So always you remember that this side you have bacteria, and this can stand also when you stain. Okay? You get this point?
Yes.
Okay. Now when you do this, this is dry. I will pass this 2-3 times in the loop, in the burner on top of that, so the bacteria, they get stuck to the slide. If I don't do that, when I put liquid dye color, everything will wash off and I will get nothing. Okay? Got it? So, flame your loop, sterilize it, take a drop of water, mix, air dry, heat fix. In liquid culture, when liquid culture is there, you sterilize your loop, take the liquid culture, take 1 or 2 loops, just mix. No need for water, it's already water. Yes, everything else, but no distilled water. Okay? We'll do it, don't worry. Now, stain the smear. Okay? Stain the smear. Then you put the slide on the sink, like this, you will have the slide, like this you put, okay? And you will stain. You got it? If you make a good smear, you make a good stain. If you don't make good smear, you make bad stain. Okay? So smear is, sterilize your loop, take drop of water, mix, make big, thin film, like you said in hematology, thin film. Okay? Then air dry, not Vukayab, not, okay? And then you fix it. Make the bacteria stick to the slide. Okay? Got it? Next thing. This is just, again you have, normally for solid we can use the needle also. That's called an inoculation needle. Yeah, we can use this also for solid culture when you're taking the colony. But it doesn't matter, you can use the loop also. So for solid, you take drop of water, mix bacteria, air dry, fix. Okay? For liquid, you just take 1-2 loops, you spread, you air dry and fix. Okay? Okay. Simple stain, just I told you, you can just put colors and you will see bacteria like this. Differential is gram stain and acid fast stain. So gram stain, this is how you do. The smear is ready. You take the first dye, crystal violet, okay, and you put it on the slide. You mix and put on the slide. All the bacteria there will become blue or purple, like this. You see here, all of them have same color. Okay, this is first step. You do this for 1 minute, and wash. 1 minute, wash. Okay, I'll write the steps, don't worry. So you put dye, wait for 1 minute and wash with water. Next step, you put iodine. It's called Lugol's iodine. What it does, it makes a complex that fixes into the peptidoglycan layer so it cannot come out, and all the cells become blue-black. You do this for 1 minute and you wash. 1 minute, crystal violet, wash. 1 minute, Lugol's iodine, wash. Then the next step is acetone. It's not alcohol, it's acetone. Okay? The step is called decolorization. In this step, what happens? We take out color from the bacteria. Okay? So if you see here, some bacteria are already blue-black, some have lost color. Like these have lost color. When we put acetone, gram-negative bacteria will lose their color because they are thin peptide protein, because of the membrane. The color will come out and they will become again colorless. Gram-positive will not give out color. Gram-positive will not give out their color. It's fixed. Alas, one time the spot comes, whatever you do, it is not going. It's like this, fixed. Okay, then you wash. It's not 30 seconds, not 1 minute, 10-20 seconds you just wash with acetone and then you wash with water. After every step you wash. The next step is saffroning. Well, there is slight confusion in saffroning. Some say 30 seconds, some say 2 minutes, but we use both. You can use 30 seconds. You put saffron in for 30 seconds. What will happen? Only the bacteria that were colorless will become red and pink. When these become red and pink, okay, this shows you two types of bacteria. The purple or violet color or blue
Positive.
color are gram-positive and the red are gram-negative. If you start from here and there were only gram-positive, they will become purple. If you start from here and if there was only gram-negative, they will only appear red. You got it? Okay. Once more, simple. You make the smear, you put crystal violet. 1 minute wash. All cells take up the dye. You put glucose iodine, all cells appear blue black. Then you decolorize with acetone. Gram positive retain the color. Gram negative are decolorized. And when you put counter stain means second stain, that is red color, gram positive blue black and gram negative appear red. Simple.
Doctor,
Yes.
all this when by one symbol of bacteria.
All this for?
I just add the stain and wash
Yes, same one.
in the same slide.
Same slide. Okay? Okay, so crystal violet, iodine, acetone, saffron. This is the CIA for Saudi Arabia. Okay? Crystal violet, iodine, acetone, saffron. So you remember. Okay? So this is what?
Gram positive. Positive.
Positive or negative?
Positive.
Saf? Okay. Sir, टोको का बस ग्राम पॉजिटिव वाला negative.
This is negative.
Now bacteria. This is bacteria? Oh, good.
This is RBCs.
MashaAllah. This is the good thing about hematology. This is RBC. Yeah, see, RBC don't have nucleus. White blood cells. Okay? It can be multi-lobe nucleus, you see so clearly. Right? So this is not bacteria. Bacteria is this small thing here. Okay? Okay? Don't get, if I put like this is bacteria. Okay? RBC is double, this Murphy nucleus. There is nucleus in RBC? So you see nucleus? Multi-lobe nucleus. It can be WBC only. Okay? Polymorphonucleus. So, what do you see? Hazarot?
Positive.
Tokay chains.
Positive. Negative.
Negative. Okay, this is not positive. This is the next that is called. Some bacteria don't have cell wall. So gram chain does not work on them. They have only membrane. And those are called mycobacteria. You know tuberculosis. Tuberculosis, you know? TB, yes. So that bacteria is called acid-fast bacteria. This bacteria does not have cell wall, so gram stain does not work on it. You cannot stain this with gram stain. There is special technique of seeing this bacteria that is called acid-fast stain or ZN stain, Ziehl-Neelsen. Heard of it? ZN stain or Ziehl-Neelsen stain. I showed you here somewhere. Wait. It's in the start somewhere. You check the spelling for it, okay? Because you will have problem there. Here. Ziehl-Neelsen stain or acid-fast stain, same thing. Okay? Yes. Mycobacteria. Like TB, like leprosy. Okay. So what is, we are about to finish, Halas. So, The presentation, okay, not the practical. So, in this stain, we have to get the dye inside the cell. Inside the bacterial cell, not only the cell wall, inside the cells. So what we do, we put hot carbon, after making smear first. We put hot carbon fusion, this is red color dye. And heat. When we are heating from the bottom, it breaks cells, goes inside. All become red. Okay. Then what happens? We wash with acid. We wash with acid alcohol, HCl. What happens? Non-acid fast give out color. Non-acid fast give out color, but acid fast, that is mycobacteria, keep the color. That is why the name is acid fast. Even with acid, you cannot decolorize the bacteria. Then you put methylene blue, and the non-acid fast bacteria, that is gram-positive, gram-negative bacteria, if they are there, they will become blue. And acid fast will become red. The first color they will keep. So even if with acid, they will not give out the color. Like gram-positive, they keep the first color. This will keep the first color, the red color that you give them first. Okay, so red, wash, doesn't give out color, keeps red. Yeah.
Non-acid fast will not appear until I put blue.
Yes. Because you have to check now. You don't know if it is acid fast or non-acid fast. Okay? Carbon fusion. This is red color dye which is used for staining. Okay? So you see here, the M it shows you mycobacteria. You see here, the arrow, it shows you mycobacteria. It's a bacillus. Okay? So now, please answer this area so we can start. What is the sequence?
The first carbon, CBA.
Before you go, you have to do all this. So now we'll do the practical. Half of you will go to the next lab. Ustad Bashir is there and he will do half of it. And half of you will stay here. Okay, you can divide group 3 stay here, group 4 stay here.
Group 4 هنا.
Whatever group stays here, one of you stay here. Okay? I don't know. Any one of you will stay here and one of you will go to the other lab. Because we can't do this all together. And today you are not that many. So Rashid, you are finished, and half of these guys will go with you to the other lab. Please, please, please. Hurry up. Alas.